Venus looks like a golden jewel hanging in the night sky. It's the second planet from the Sun and often called Earth's sister planet because it's almost the same size. But don't let its beauty fool you. Venus is pure hell. With temperatures hitting over 860 degrees Fahrenheit, hot enough to melt lead, an atmosphere 90 times thicker than Earth's, and constant sulfuric acid rain falling from yellow clouds. And yet, today we're designing a mission to send humans to this extremely hostile world. How would that even work? And more importantly, why would we do it? "4 billion years ago, Venus might have looked very different. Scientists believe it once had oceans of liquid water, an atmosphere similar to Earth's, and maybe even microbial life. What happened to this once potentially habitable world is still one of the biggest mysteries in planetary science. A runaway greenhouse effect turned Venus into a cosmic oven. Its atmosphere is now 96% carbon dioxide with thick clouds of sulfuric acid. Winds whip through the upper atmosphere at over 220 miles per hour, tearing the skies into storm systems that can last for months. So, why do we even care about Venus? Because the answer might tell us something crucial about Earth's future. Climate change on our planet is showing disturbing trends: rising CO2, intensifying greenhouse effects, and global temperatures on the rise. Venus is like a natural time machine, a glimpse of what could happen if we don't take action. And beyond that, Venus holds clues to how rocky planets evolve inside the habitable zone. If we want to understand how Earth-like worlds form and survive, we need to figure out why Venus took such a different path. There's one place on Venus where humans might be able to survive. A place most people would never think of. 50 kilometers, about 30 miles, above Venus's scorching surface, things start to look surprisingly familiar. Up here, temperatures drop to somewhere between 30 degrees Fahrenheit and 140 degrees Fahrenheit. Still hot, but survivable with the right tech. Even the atmospheric pressure is close to what we have at sea level on Earth. NASA's got a concept called HAVOC, the High Altitude Venus Operational Concept. Imagine a floating research station, like a giant high-tech blimp drifting through the upper atmosphere of Venus. It's a massive airship filled with helium, using the planet's thick CO2 atmosphere for natural buoyancy. But here's the catch. Building something like this isn't easy. How do you make a structure that can survive corrosive sulfuric acid? How do you provide breathable air when the atmosphere is pure poison? And where do you get water on a planet that lost all of it billions of years ago? Engineers propose a closed-loop system, recycling every single molecule of air and water. The habitat walls would need to be coated in super-resistant materials, like PTFE, yep, that's Teflon, and corrosion-proof metal alloys. Air filtration systems could extract oxygen from the carbon dioxide using advanced electrolysis tech. Life inside the floating habitat would feel very different. Venus's gravity is about 90% of Earth's, so astronauts wouldn't suffer bone loss like they would on Mars. But stepping outside? That's off the table, unless you're wearing a full-body suit built to handle acid rain and crushing pressure. But before we can build a city in the clouds of Venus, we have to survive the most dangerous journey in the history of human space exploration. Getting to Venus isn't exactly a walk in the park. Even though it's the closest planet to Earth, the closest distance is still about 16 million miles, That's roughly 65 times the distance from Earth to the Moon. Unlike a trip to Mars, which can use the relatively simple Hohmann transfer orbit, going to Venus takes a much trickier strategy. The big challenge? Timing. Launch windows to Venus only open every 19 months when the orbits of Earth and Venus line up just right for the least energy transfer. Even then, the trip takes around 4 to 6 months, depending on the exact path chosen. But it's not the distance that makes this trip so brutal, it's the sun's radiation. The closer you get to the sun, the more intense the radiation astronauts have to deal with. At Venus's orbit, the solar radiation is twice as strong as what we experience here on Earth. The spacecraft needs thick, multi-layered radiation shielding made from materials like tungsten and polyethylene. Cooling systems have to work overtime to keep sensitive electronics from frying. Even with the best protection, astronauts will still be exposed to significant radiation, raising their risk of cancer and long-term DNA damage. During the journey, astronauts will live in tight quarters, not much bigger than a small bus, for months on end. Life support systems must run flawlessly, no room for error. There's no rescue mission if something goes seriously wrong in the middle of space. Every system has a backup, and every backup has a backup. Food, water, oxygen, and power all have to be calculated with surgical precision. One wrong move could mean death for the entire crew. If you've made it this far, you're probably wondering how we land on a planet with no solid surface. Drop a comment below. What do you think is the biggest challenge about landing on Venus? But landing on Venus isn't like landing on any other planet. What you're about to hear might sound like science fiction, but it's the only way it might actually work. Landing on Venus is a procedure humanity has never attempted before. Unlike Mars with its thin atmosphere, or the Moon with none at all, Venus's atmosphere is 90 times thicker than Earth's, like diving 3,300 feet below the ocean surface. The Soviet Union is the only country to have landed probes on Venus's surface. But even specially designed robotic probes survived no more than 2 hours before the extreme conditions destroyed them. Venera 13, the longest survivor, sent back the first color photos of Venus's surface before its components melted. For a crewed mission, the strategy must be completely different. Instead of landing on the surface, the spacecraft will perform the most complex atmospheric entry ever designed. It will dive into Venus's atmosphere down to about 31 miles, where the floating habitat will be deployed. Step 1. A massive heat shield will protect the ship from friction heat reaching 1,832 degrees Fahrenheit. This shield must be far more advanced than those used for Mars missions or Earth re-entries, because Venus's atmosphere is denser and highly corrosive. Step 2. At around 50 miles altitude, a special parachute system will slow the descent. But this isn't any ordinary parachute. It must be made of acid-resistant materials capable of functioning in dense CO2 atmosphere. Step 3. At 37 miles altitude, the floating habitat will be released and inflate its giant helium balloon. Timing is everything. Too early and the habitat will plunge too deep into Venus's hellish atmosphere. Too late and it won't reach the habitable zone. Step 4. The mother ship will fire its engines one last time to exit Venus's atmosphere and return to orbit, leaving the crew safely floating in the upper atmosphere. What makes this mission extremely dangerous is that there's no second chance. If the balloon system fails to inflate, the habitat will crash to the lethal surface within minutes. If the heat shield fails, the entire mission ends in disaster. Every component must work flawlessly on the first try. Engineers have spent years designing backup systems for every possible failure. The habitat carries multiple balloons that can inflate independently. The heat shield has layered protection to withstand partial damage. Even the navigation systems have multiple redundancies to ensure the habitat lands in the target zone. But even after reaching Venus's habitable zone, the biggest challenge has only just begun. How do you survive in the most hostile environment in the solar system? Life inside Venus's floating habitat will be the ultimate test of human endurance. Imagine living inside a balloon suspended above a sea of acid, where a single tiny leak could mean death in seconds. Every day, astronauts must monitor hundreds of critical systems. Air filtration runs every day, converting toxic CO2 into breathable oxygen. Water recycling processes every drop of liquid, from drinking water to human metabolic waste. The psychological challenge may be even greater than the physical one. Astronauts will never see the sun, hidden behind thick acid clouds. They will never feel fresh air or breathe natural atmosphere. For months, they will live in a confined space, staring at the same endless yellowish clouds. Scientific missions on Venus will be intense. Each day, astronauts will send small probes deeper into the atmosphere to collect gas samples and measure chemical composition. They will study mysterious wind patterns, trying to understand how giant storms can last for months. Communication with Earth will have delays of 4 to 24 minutes, depending on the orbital positions of the planets. In emergencies, astronauts must handle problems on their own, without real-time help from mission control. Every decision could mean life or death. Many hydroponic systems will provide limited fresh food, perhaps some leafy greens and small fruits. But most food will be specially processed rations designed to last. After months, the extremely limited food variety will become another psychological challenge. Medical emergencies will be extremely dangerous. No hospital, no specialist doctors, no emergency evacuation. Astronauts must be trained to manage a wide range of medical conditions, from appendicitis to broken bones, with limited equipment. To maintain mental health, astronauts will follow strict routines, daily exercise in tight quarters, scheduled communications with family on Earth, and creative activities like journaling or painting Venus's cloudscapes. You must be wondering, when will they come home? The final part will blow your mind. Don't miss it. Returning from Venus may be the most dangerous part of the entire mission. Unlike Mars, where astronauts can use the planet's surface as a launching pad, Venus explorers must be picked up from a habitat floating in the middle of a poisonous atmosphere. The rescue ship has to perform the most precise orbital rendezvous in the history of space exploration. It must dive into Venus's atmosphere at the exact speed and angle, meet the floating habitat swaying violently in fierce winds, and transfer the crew within an extremely limited time window. What makes this almost impossible is the complete lack of stable navigation references. On Mars or the Moon, spacecraft can use surface landmarks for navigation. On Venus, everything changes constantly. Clouds shift, winds change direction, and there is no fixed reference point. The rescue ship must rely on advanced radar and LiDAR to track the floating habitat's position. These systems must operate through acid clouds that obscure visibility and interfere with radio signals. The margin for error is razor thin. A mistake of just a few kilometers could mean mission failure. The crew transfer will use a special docking system never before attempted. Astronauts must move from the floating habitat to the rescue ship through an airlock designed to operate in a high-pressure CO2 atmosphere. Once the crew transfer is complete, the ship must perform the most aggressive escape burn to break free from Venus's gravity and dense atmosphere. No second chances, fuel is limited, and the launch window is incredibly narrow. The return trip will take another 4 to 6 months, facing the same radiation challenges as the outbound journey. But this time, astronauts will bring back precious Venus atmospheric samples and invaluable scientific data about the evolution of a planet that might once have been habitable. When they finally touch down on Earth, the Venus astronauts will be the first humans ever to visit another planet and return to share their first-hand experience of living in an actual hellscape. A mission to Venus might sound like science fiction, but the technology is already being developed today. What do you think? Should humanity take the risk to go to Venus? Write your thoughts in the comments, and don't forget to subscribe for more space content.